So let's just talk about the question. Okay, so we have got three triangles that we are going to apply to, or rather use. So we have got PRS, is the bigger one, which means in this case we don't need triangle RQS. For this question, it's not going to help us. Okay? So first thing I'm going to say, in triangle PRQ, okay? In triangle PRQ, I need to get the length of PR, because if I'm going to use the cosine rule, I need the length of PR, I also need the length of what? PS. Okay? So, I'm going to say, okay, I have to use trigonometry. So if I get PR, that's my hypotenuse. So my reference angle is 30, so that's opposite over hypotenuse. So that will be sine 30 is equal to the opposite side, which is x over PR. So PR is going to be equal to x over a half, which is equal to 2x. Okay? So my PR is 2x. Then in triangle PQS, I need to get PS. So my reference angle is going to be that 30 degrees there. Okay? So I've got that 30, so it means I'm going to say it's going to be adjacent here. This is the adjacent side. So I've got the hypotenuse there. So I'll use cos there. So that will be cos 30 degrees is equal to x over PS. So PS is going to be x over square root of 3 over 2, which is the same as 2x over root of 3. Okay. Right? So I've got my PR, I've got my PS. Now I need to just apply the cosine rule. When I apply my cosine rule, it will be in triangle PRS. PRS. But be aware that for triangle PRS, my angle, my given angle is going to be that theta there. So when you write your cosine rule, you need to be very careful as to which sides are you going to be looking at. So in this case here, I can write my cosine rule. Since theta is our reference angle there, we are going to, it is between PS and RS. So my cosine rule is going to be PR squared. PR squared is equal to PS squared plus RS squared. So that will be PS squared plus RS squared minus 2PS times RS cosine of theta. Then our PR, we got it here, it's 2x, so that will be 2x squared. PS, we have got it there, it's 2x over root 3, so that will be 2x over square root of 3 squared, plus RS, which is given there as root 3, so that will be root 3 squared, minus 2 times 2x over root 3 times RS, which is root 3 times cos theta. Okay, now we should be smiling there, so we get 4x squared. Okay, this one here will give us 4x squared over 3 plus 3 minus 4. Well, these two cancel out, so I'll get 4x cos theta. I hope you can see that those two cancel out. And then here, I have to multiply every 10 by 3. Okay, so I'll get 12x squared. That's how we end up coming up with this 12, with this 12. Right, so that will be 12x squared is equal to 4x squared plus 9 minus, okay, I have to multiply that by 3, so we've got another 12x. So I think this one here, it doesn't, it's this one here which has to come out, so that will be that. Then these two are like terms, so they'll give me 8x squared is equal to 9 minus 12x cos theta. So I want cos theta, so this becomes cos theta equal to I'll get, okay, let me put 12x here, then I'll get 9 minus 8x squared, and then I'll divide both sides by what? By 12. Let me just check if I'm on track. Yes. So I'm on track, so I just have to divide both sides by 12x. So this is equal to 9 minus 8x squared all over 12x. And then you're back.
Marks for this picture.
Maybe 5. Okay, at least probably 5. At least 5 marks. At least 5 marks. Okay. Okay, so DE is got 2EF, so I can substitute 2EF, then I have to square this plus EF squared minus, here it will be 2 times, now this is DE, which is equal to 2EF, so that will be 2EF times EF cos 2 theta. So this will give us 4EF squared plus EF squared minus 4EF times this EF here, so we get 4EF squared cos 2 theta. Okay, then I now need to substitute my EF there. So this is also 5EF squared minus 4EF squared cos 2 theta. Then my EF is that. I just substitute it, and I substitute here, I'll get 5. Then I'm going to get h over tan theta squared minus 4 times h over tan theta squared times cos 2 theta. Okay? Then if I simplify this, I'll get 5h squared over tan squared theta minus, here I'll get 4h squared all over tan squared theta times cos 2 theta. So this is equal to df squared. So on the right hand side I've got a common denominator, which is tan squared theta.
So how many marks so far?
No, the whole question is 5 marks.
So far,
Maybe 4, 2, 3, 2, 3, because it's 5 marks. And then I'll take square root both sides. So I can write here df is equal to the square root of I've got my h here. Let me go back and see. So there's no half over tan theta over the h. So that cos 2 theta is a double angle. So I need to convert it, okay, to this one here. Okay, because we have got cos theta there. So I'll convert it to that. So that will be 5, all right, it's 5h squared minus 4h squared cos. Okay, so I'll say 5h squared minus, so 5h squared minus 4h squared, right? Then I'll convert the cos 2 theta to 2 cos squared theta, so that will be 2 cos squared theta minus 1. This is all over tan squared theta. Then your knowledge of sets here is required, right? How to work with the square root. So I can take out a common factor, which is h squared. So if I take out a common factor, I'll have h squared times 5, get minus 4 times 2 cos squared. Okay, that will give me 8. But I think, let me just rewrite it to avoid unnecessary silly mistake there. Right, so this is all over tan squared theta. Now this is a perfect square, so I can find its square root. This one here, I can find this square root, take the h outside. So I can have h here, open bracket. Okay, so let's simplify it now. So, this is, okay, this one it can remain inside, so I can multiply it. So I'll get 5 minus 8 cos squared theta minus, okay, that becomes a plus 4, okay, that becomes a plus 4. So plus 4 over tan squared theta. And these two will create a perfect square, which is a 9. Let me just check if I'm on track. Yes, I get that 9. So I'm almost done now. And let me go to the next page. So next page I'll get my h. Then this will multiply 9 minus 8 cos squared theta. That will be all over tan theta, because this is a perfect square inside the square root. So I can find the square root. And then we'll be done there. So that's d what?
Yes.
Okay. So you get short. Okay.